So hello everyone and welcome to my talk. So I hope it's been a very good day for all of you. I'm sure you've learned a lot of new things about Kotlin today. So first I want to know how many of you are Android developers? And how many of you are using Kotlin for backend or other projects? Oh, okay. So today I'm going to talk about code generation with annotation and KotlinPoet. Before I begin, let's do a quick introduction about myself. My name is Melvin Sutanto, and I'm a software engineer at Wantedly. I'm developing an Android version of our app called Visit, and I've been developing for Android with Java since 2013, and I've been working with Kotlin for the past year or so. And at the bottom there, you can see my Medium or Twitter handle if you'd like to give me a follow. So before I talk about code generation, let's touch briefly on the concept of metaprogramming. This is a very simplified version of this concept. If you'd like to dive more into this topic, I will give you a link in one of the slides later. So metaprogramming, if you go by the definition, is a program that uses another program as its data. This data can then be used to alter or change the behavior of the program or add extra functionalities to the program itself. This concept is very common, for example, to help us reduce boilerplate codes. And we can divide this concept into two groups, depending on when it is run. Reflection and parser, if we alter the behavior of the program during runtime. And generator, where we add functionalities to the program during compile time. In reflection, we can read files and properties of our program during runtime. And in Java or Kotlin, we can read classes, variables, functions, and modifiers. We can even invoke private functions through reflections. Not only that, we can also read and interpret other file types, such as JSON or XML files, and then add functionalities based on that. However, this pattern is generally considered a bad practice because it will add processing overhead and can impact the performance of your application. It is very brittle and doesn't work well with code obfuscation tools like ProGuard or R8. In the generator pattern, we generate files based on input data. And in Kotlin, the input typically comes from annotation, but it can be from any input or files. It can generate source code, bytecode, or any arbitrary type of files. And since it is run in compile time, we can add validations and checks to allow it to be compile safe. That is, if there's an error in the generator, we won't be able to build our application, and this is good to ensure that we don't encounter any unexpected bug during runtime. Generator pattern also offers better application performance because the code is generated during compile time. And one of the most popular libraries that uses this pattern is Dagger2 for dependency injection. In Dagger2, variables that have been marked with inject annotation will be injected by Dagger down the line. In this talk today, I'm going to show how we can implement one of the most popular implementation of the generator pattern, using Annotation Processor to generate Kotlin source files. annotation processing works by using the Annotation Processor API that is available since Java 6. And with this API, we can process elements that have been annotated with an annotation. Do note that the processor reads a representation of our code, not the code itself. During the annotation processing step, our code has not been compiled yet, and we will need to use special APIs to read our classes. So the topic of annotation processor can be really big. And since we can technically generate any type of files depending on our needs. So to better explain this topic, I'm going to build an annotation processor that generates an extension function that converts a data class in Kotlin to a map. This is how our annotation and generated code will look at the end. Here we have a data class that is annotated with our custom annotation automap. And then here we have a generated extension function that converts that class to a map with the name of the variable as the key of the map and the value of the variable as the value of the map. If the type of a variable is also annotated with automap, we will use the generated toMap function of that type instead of its value. Of course, there are other more useful applications of this concept, but I thought this is simple and short enough to showcase the usage of annotation processor. So to create an annotation processor, first we need to create the annotation class itself. So let's create a module called annotation that will contain our annotation class. It is important that this annotation module is an independent module so that we can easily add the dependency to this module from other modules. For Android developers, note that this module needs to be a Java or Kotlin module and not an Android library module. And this is how the annotation of automap class will look like. Here I added target annotation and set it to target class because I want this annotation to be applicable only to a class type. There are other annotation targets as well, such as property, parameters, functions, and so on and so forth. Then I've also added retention annotation and set it to source. This basically means that the annotation will only be available during compile time and will not be included in the binary of the compiled app. And since we are going to use the annotation only for compilation, and this is good for us. Next, let's create a processor module that will process our Kotlin code. This again is a separate module from the main application module and the annotation module. Since we'd like to add the dependency to this processor module using KAPT. We will also add the dependency to the annotation modules and also a few other libraries that will help us build our processor. I will explain the usage of each one of them later. Also note that this processor module also needs to be a Java or Kotlin module instead of an Android module. And this is the dependency graph that we should have for our annotation processor. So let's create a class that is going to read our annotated Kotlin source code. To read Kotlin source code easily, we are going to add Kotlin metadata library that exposes the Kotlin metadata in a type-safe manner. Kotlin metadata is an annotation that is added to our compiled class and is used to describe Kotlin-specific features and flags. It looks something like this. And I'm not going to explain the meaning of each property, but if you want to know what does each field means, you can take a look at the Kotlin metadata documentation. And of course, there are other methods that you can use to read Kotlin metadata. So there's a library from JetBrains to read Kotlin metadata called KotlinX metadata. Personally, I think the Kotlin metadata, which is the one that we are going to use today, has nicer APIs and is used by a lot of popular open source libraries like Moshi for JSON serialization. But we might want to look into KotlinX metadata in the future. So let's create our processor class and name it AutoMap Processor. As you can see, we extend from Kotlin Abstract Processor and implement Kotlin metadata utils. This class and interface from Kotlin metadata library provide utility methods to access Kotlin metadata. We then override get-supported annotation types and return only the annotation that we are interested in. Overriding this method will let the processor API knows that we are able to process elements that are annotated with our annotation. There are other options that we can override for the processor, like Annotation Processor options and minimum supported Java source code version. But for our example, this is good enough. The next important step is to register our processor into the compilation flow. To do that, we are going to use another library called AutoService. Of course, we can register this manually, but that can be quite hard to maintain. And to use this library, we are going to add implementation and KPT dependency to the AutoService artifact. And then annotate our processor class with AutoService and processor class as the argument. Before we add code to our processor to process Kotlin source files, let's take a step back and look at the terminologies used in Kotlin syntax. This is important since we are going to work with metadata of a Kotlin code. So we need to make sure that we are referring to the same thing using the same terminology. This is a class in Kotlin, or sometimes referred to as a type. A type can also be an interface, an annotation, a primitive, or an enum. Each type can have members, and members can be variables or functions. Each function can have 0 or more parameters. And in Kotlin, there's also a top-level member, which is a function that is not declared inside any class. For example, extension function. We also have a return type of a function. And lastly, we have the visibility modifier for members and types. This is the terms that we are going to use today. Of course, you can use whichever terminology that you prefer for your day-to-day work. Since now we are using the same terminology, we can start adding code into our processor. Inside the process function in our processor class, we are going to get all the elements that have been annotated with AutoMap. To do that, we are going to use run environments get elements annotated with and pass in our annotation class as the parameter. This will return a list of elements, and each of these elements can be a class, a function, a variable, or a parameter, depending on the target. We will then go through each element and check if it's a public data class, and then read the variables that are declared inside each element, and check if the type of a variable inside the element has also been annotated with automap, and then generate the extension function with KotlinPoet. Even though we've set the annotation target to the class itself, it's still a good practice to check that the element is an instance of type element. And also check that the element has metadata of type Kotlin class metadata. With Kotlin class metadata, we can get a reference to a class proto. This class allows us to read properties of a Kotlin class. For example, we can get a list of constructors, supertypes, type parameters for generic types, list of functions, and modality of a class. So we will use class proto in this example to check if an annotated element is a data class, is a public class, and is not an inner class. Now that we know that each element is a public data class, we can then get the declared variables inside the data class. To do this, we will use element.enclosedElements, and then check if each enclosed element is an instance of variable element, because enclosed elements can also return an instance of executable element, which is a function. We also want to check the type of our variable, because we want to use the toMap extension function if our variable has been annotated with automap. To do this, we will make use of type utils from the Kotlin metadata library. Then check the type if it has been annotated with automap. Next, we create a pair of the name of the variable using simple name of the variable element and the type of that variable if it has been annotated with an annotation. This information about the type will be used when we generate the extension function using KotlinPoet. This example that I showed here used the declared variables inside a data class. But since we are using Kotlin data class, we can also use class proto to get the primary constructor and use the list of parameters as a list of variables. And now that we have a name and type of each variable inside our data class, we can then proceed to write a generator to write our Kotlin file. To do that, we are going to use a library called KotlinPoet. So KotlinPoet is a library by Square that allows you to easily write Kotlin source files. I recommend you to read the full documentation in KotlinPoet's GitHub page, but we will use some of the features of KotlinPoet in this example. We can add the dependency to KotlinPoet into our processor modules dependencies block, just like a normal library. But based on my experience, I find it easier to use KotlinPoet if we know what does the code look like at the end and work from the innermost block to the outermost block of the code. So let's take a look again at the function that is supposed to be generated by KotlinPoet. Here we have a class person that is annotated with automap annotation. And we have an extension function called toMap as a top member function with the receiver type of a class person and return a type of map of string and nullable any. Inside the extension function, we call another top member function map_of from the Kotlin standard library and assign it to a variable map. Inside map_of, we then iterate through all the variables that we previously read and create an entry of the variable's name to its value. If the type of the variable is also annotated with automap, we will then call toMap extension function on that variable. The innermost body of this extension function is the code that generates a map using a map_of function from a list of variables. So we are going to create this block first. To do that, we will use CodeBlock class from KotlinPoet. This is going to be a bit complicated, so please bear with me. CodeBlock is a class that represents a fragment of a Kotlin file, and it can potentially contain declarations, statements, and/or documentation. It heavily makes use of placeholders, and I'll show you what does this mean. Here I added the statement val map :%t equals %m open bracket. %t and %m are placeholders, and they will be replaced by the parameters that you pass to the function, just like string.format. %t is a placeholder for a type, and %m is a placeholder for a top-level member. Using the correct placeholder will allow KotlinPoet to automatically add the import statements to the generated source file. For %t, we want to pass the type of the map, and since it's going to be a map, which is a generic type, we will use a class called parameterized type name to construct the return type. To create a parameterized type name, we use +parameter function of a class name. Class name is a very important class in KotlinPoet because it allows KotlinPoet to get the correct reference to a class type. The first +parameter is for our string type, and the second +parameter is for our any type, and we are going to set it to nullable. For our %m, we want to pass a member function map_of from the standard Kotlin library. And to be able to import and use this function correctly, we will create a member name for map_of. Note that in the beginning, we only have an opening bracket, because we are going to add the closing bracket later at the end. And we're also going to add indent and unindent statements so that our generated code is easier to read. Lastly, we are going to add the return statement of the function. We will then iterate through the list of pair of variable names and the type that we had created previously, and create a statement for each pair. If the type of a variable is not null, if you remember, means that it is another class that has been annotated with automap, we are going to call toMap extension function that we know is going to be generated by our processor. Otherwise, we are going to pass the value as is. You'll notice that we are using two more placeholders here, %s and %l. So %s is for string output, and it will put quotation marks around the parameter, while %l is for literal, and will print the parameter as is. So the first name parameter will be the key of our map, which is the name of the variable surrounded with quotation mark. And the second name will be for the value of the map accessed through the name of the variable. Then we will add the completed code block to a fun spec of a toMap function. FunSpec is a class that we will use to specify the generated function. So let's go back and see the extension function that we want to generate. The inner body of the function is complete, and we will move to the next layer of our code. Here we want to specify that this function is an extension function of a receiver type person, and it returns a map of string and nullable any. Adding on to the FunSpec that we had created before for our code block, we will then specify the receiver type by passing in the class name of our element. Next, we will specify the return type of the extension function. And since the return type of the function is the same as type as our map, we can reuse the same type that we had created for our code block. There are other options for FunSpec that we can use to specify our function. We can add kdoc for documentation. We can add extra parameters, annotations, modifiers. You can also add control flows like if or when statements, and much more. And now we have a completed FunSpec for our extension function. We will add the FunSpec to a FileSpec. FileSpec is a class that we can use to specify the generated file. To create a FileSpec, we will use FileSpec Builder with the package name and the name of the file. And then, since we are going to add an extension function, which is a top-level member, we are going to add our FunSpec directly to the FileSpec. We can also add other options and elements to a FileSpec. For example, you can add a type through a TypeSpec. You can also add annotations or global properties to a file. And since we are good programmers, we are going to add documentation to warn other developers that this is a generated file and it should not be edited. And to do that, we will use add kdoc to our FunSpec and add command to our FileSpec. And as usual, you can make use of placeholders. And we are now ready to write our file. So we just call build and then pass in the output folder path to the write-to function. And this is how the final generated Kotlin source file will look like. Now we have a working code generator. You might be wondering how we can test our annotation processor. Of course, you can, just like any other application, you can compile and run the application and then test it manually. But I think there are other ways that we can use to automate this process. One of the easiest way to do that is to create a separate module that contains only the test classes that we want to test. Add the annotation to the test classes and then invokes the generated code. Using the example code that we've built, we will create a module that tests our generated toMap function and ensures that it is producing the correct value. Here I created a person object with a null value for the name property, and then check if the map from the extension function has an entry with the key name but has a null value. However, this is only good for testing happy path and does not allow us to test the error case for our processor. Because if there's an error in the processor, the compiler will fail and we won't be able to access any of the generated files. If we want to test the error case of our processor, we can use the Kotlin compiler. Luckily, we have some libraries that helps us to do just that. Some of the popular libraries that we can use are Kotlin compile testing and compile testing. they both works very similarly. Basically, we will add the source files, we will add the dependency as a test implementation to the processor module itself, and then write the source code in string format, or we can also load it from a file, pass it over to the compile API provided by the library, and then validate the compiler's result and generated classes. This sample code for testing annotation processor is written using Kotlin compile testing, where we use the Kotlin compilation object to set up a basic annotation test. We pass a list of source file and a list of annotation processors that we want to be run by the Kotlin compiler. Once the compilation is run, we check if the exit code returns OK, and then loads the generated classes and assert whether we have the generated extension functions. However, since this will load the compiled classes and our Kotlin extension function will become a static function inside a class file in Java, we will have to check against this class instead. And also with this method, as I mentioned before, we can test the error case of our annotation processor. For example, here I added the annotation to a non-data class, and we should see that the exit code of the Kotlin compiler indicates a compilation error. And with this type of automated test, we should be able to better maintain our code generator. So now we have seen what code generation with annotation and KotlinPoet can do for us. However, we have to think about some of the limitations before building our next code generator. First, we need to be careful because code generator can increase the build time of our application. Since all steps need to be performed during the compile time, adding too many processors can introduce additional overhead to the compilation time. One way to fix this is through implementing incremental annotation processing. Incremental annotation processing means that the annotation will not be run if it doesn't find any changes to the annotated elements. And this can be useful to improve the performance of your annotation processor. It's been supported since Kotlin 1.3.30, and some of the most popular libraries have also added support for this. Another important thing to consider is that an annotation processor cannot be used to modify an existing file or class. It can only be used to create additional classes to be used inside our applications. And depending on how much code we generate during this process, you can add additional code footprint and increase the overall size of your app. Lastly, there's also the problem where the generated code is not available until KAPT is run at least once. And if there's an error during the generation process, we might encounter a lot of unresolved reference error, and it can be very confusing in determining the root cause of the error itself. My advice to you, if you'd like to build an annotation processor for your next project, is to think carefully about the reasons why you need an annotation processor. So annotation processing is good if you'd like to access the members of an element and then generate code based on that information. When creating an annotation processor, the API of the generated code, that is how you're going to use your application, is going to be more important than the readability of the generated code. So create an API that is Kotlin-like. For example, use extension functions, make use of lambdas, and also create DSL through the generator. Annotation processing is also very good in dealing with repeated codes, so that you can easily automate this process and reduce boilerplate codes, and focus on building the features that your users need. Lastly, it will be very tempting to build annotation processor for everything once you've made your own annotation processor. But be very careful about the time investment that you have to spend in order to build, test, and maintain your code generator. And also, don't always think about an annotation processor, because sometimes interface and abstract classes are all that you need to achieve your use case and is generally less time consuming. To get a better idea of what kind of annotation processor that you can build, I will touch on the custom annotation processors that we've built at Wantedly. We built an annotation processor that reads the variable of an annotated class and then creates a list of variable names. If the variable is a primitive type, we are going to use the name as is. But if the variable's type is also annotated, we will then add the names as a nested element. This list of variable names is used for APIs that requires you to pass a list of fields to that requires you to pass a list of fields that you want on the response object. And this annotation processor allows us to add the list of field names into the API request without adding them manually or adding them through reflection. Another implementation of an annotation processor that we have is for analytics. This annotation processor accepts annotation on a Kotlin Shield class and then generates a map of parameters that we can easily pass to an analytics library. This implementation is very similar to the annotation processor that we've talked about today. I wrote a blog post that describes the step-by-step implementation of this annotation processor, and I've also provided some sample project in the article. If you'd like to know more in detail, you can find it in my Medium page. And with that, I think that's all I have to talk about today. I think this is a bit faster than it's supposed to be, but I hope you find it interesting and useful. Here's a list of references that you can use if you want to learn more about annotation processing in Kotlin. And thank you very much for listening.